Moving on to the next question, which is asked from the subject measurements in the series 2 for W and IN. So here the question is for 2 marks, which is also from the topic measurement of basic electric quantities 1. So here an ammeter voltmeter method is used to measure a resistance, and the circuit to measure the resistance is shown below. This is how they have connected the experiment to measure the unknown resistance. So the reading of the ammeter and voltmeter are 0.3 amperes and 2.4 volts respectively, and we know, and the resistance of the voltmeter is given as 450 ohms. So what is the percentage error when you measure the unknown resistance in this kind of setups? So always here the error comes into the system due to the instrument which is connected towards my left side. Here the instrument which is connected towards my left side is ammeter, so ammeter always is going to create an error in the reading. So we need to calculate the percentage error. So percentage error is given as measured value minus true value by true value. So here we know the measured value, which is nothing but the readings of both the ammeter and voltmeter. So we know that ammeter read 3.3 amperes and voltmeter read 2.4 volts. So the unknown resistance is nothing but V by I, which is nothing but 2.4 by 0.3, which comes as 8 ohms. Here the 8 ohms is nothing but the measured value, which is from the ammeter and voltmeter reading. So now we need to calculate what is the true value to calculate the percentage error. So the true value of resistance we can calculate when we know the current through the resistance. So I'm basically going back to the same formula, V equal to IR. So we need to know what is the current flowing through the resistance and what is the voltage across it. So here we know from the setup that the voltmeter is in parallel with the unknown resistance, so both of them will have the same voltage drop. So here, which is nothing but the voltage across resistance, we already know, which is as 2.4 volts. So we need to calculate what is the current flowing through the resistance. So here from this diagram we can see that the ammeter reads two currents basically, which is a combination of two currents, which is the current flowing through the voltmeter as well as through the resistance. So here I have written that current reading is nothing but current through the voltmeter plus the current through the resistance, which is two parallel branches, which you can see from the circuit diagram. So if I translate that into my equation, so the true value is nothing but voltage across the resistance, which is 2.4 volts, divided by current through the resistance, which I know from this equation ammeter current as 0.3 minus, I need to calculate what is the current through the voltmeter. I know the resistance of the voltmeter, which is given in the problem as 450 ohms, and I know what is the voltage across it, which is nothing but 2.4 volts. So I can calculate current through the voltmeter, which is nothing but 2.4 by 450 ohms. So when I rewrite the equation IR, I get IA minus IB. So here I have substituted that. So 2.4 divided by IA is ammeter current, which is 0.3 minus current through the voltmeter, which is nothing but the voltage across it, 2.4 by 450 ohms. So when I calculate, the true value of resistance comes as 8.14 ohms. Clearly you can see the measured value is less, which is 8 ohms, and the actual value is 8.14 ohms. So we know that percentage error is nothing but measured value minus true value by true value into 100. So 8 ohms minus 8.14 by 8.14 into 100, which comes negative as minus 1.72%. So it's a fill in the blank. So here we don't have options. So the answer is minus 1.72%.